Okay, just to introduce myself briefly, I'm Andrew Nesbitt. I was the first speaker at the Bristech meetup ever, in a very cold, dank room somewhere in the depths of Bristol. It's quite fun flying a nodecopter around the room, and I was invited back to speak as a step-in speaker, so I've kind of quickly put together a presentation about a side project that I've been working on for the past few months. I'm tbass on Twitter, Andrew on GitHub, and I also have a website as well. And what I've kind of been consumed with over the past few years of my life is the idea that software is eating the world, especially open source software, which is growing at an exponential rate. A quote from Chris Wanstroff, the CEO of GitHub, quite recently, I think a few weeks ago, said that GitHub has 25 million repositories of source code, up from 10 million in January last year, which is a huge amount of software. And as far as I can tell, there are over 1 million open source libraries, not applications, but libraries that people can use across every different programming language, which is a brilliant time to be alive. The amount of different choices and pieces of software that we have to be able to use to build things on top of is growing like crazy, and we're able to develop things faster and better all the time. In my findings, I've found that there's over 1,500 projects, new projects, published every day, and about 5,000 updates to existing projects, which is about one new library every minute of every day, which is wild. And that's absolutely amazing. This has never been so much opportunity to build on top of the shoulders of giants, to make things faster, just because we don't have to keep reinventing the wheel. We don't have to develop interfaces to databases, because the first person who does it usually publishes it online, makes it open source, and we can actually then continue to work on the things that are valuable and new and interesting, rather than keep repeating ourselves. But there is a problem. With 1 million plus open source libraries, how on earth do you know which ones are any good? So we've gotten past the stage of just finding the library that matches whatever keywords that I'm looking for is the one to use, because say we're searching for a Redis client, there are 358, this was taken a few minutes ago, Redis clients just written in JavaScript, let alone every other language. Could be thousands of Redis clients available. How do you know which of these are any good? Given that we only have a short amount of time to do any particular thing, you don't literally want to go through and try every single alternative that there is for any particular library. You just want to know which is the best one for the given point of time in the problem that I want to solve. So, what I wanted to explore today a little bit was the idea of how you can filter down, given a choice of different software libraries, how you can work out which one is the best, or at least which one should we ignore whilst we're going through, and given a wealth of options, how can we drill down to something which is going to be reliably good, so that we can just pick one and move on, and then continue to build the software that we actually care about, rather than spending our time just cycling through lots of open source alternatives. So we've got the basics. Well, if you're given a choice of libraries, how would you start off? Initially, we must make sure that the open source library itself has been properly licensed. There's about 30% of all the libraries that I've found so far have no real open source license whatsoever. And by that I mean they are literally just copyright to the person who wrote them. And although you may be able to download them and use them, legally it's a bit of a gray area if you're actually supposed to be using that in your code and depending on it. In theory, the person who wrote the code and owns the copyright, if they've not licensed it correctly for you to use, you are essentially they reserve all rights and can at any time come to you and say, you're not allowed to use this. I gave you permission to read it, but not actually to depend on it or to use it in your applications. So we need to make sure that it has a license. Fairly good way of filtering out 30% of all libraries. We can throw those away. Documentation. Now you're going to need at least a little bit of documentation to be able to use a library, because you need to be able to understand it, even if it's just a basic README. A good number of libraries, especially published on NPM at the moment, have no README or any kind of documentation, literally just the source code, which you could spend time reading and trying to understand, but we can filter out again, throw a load more away because we have no documentation. So that's another simple filter that we can work on top of. And the source code probably needs to be available. So if you can't actually see where this module is being developed, especially with languages that are compiled like Java, where you're downloading a binary from your as a open source library to use, you can't see what the code is, you can't see how it's developed. We can filter out and remove a load of projects that essentially we have no visibility on how they're developed or what their process is. So we can use those three as a baseline to go, let's not consider anything that doesn't have a library, a license, doesn't have any documentation, and the source code must be available. Bonus points for tests. You'd think that would be an obvious inclusion for a lot of libraries, that there would be some kind of tests, but that is not necessarily the case. Again, there are a lot of libraries that don't have any tests along with licenses, READMEs. They're essentially thrown out onto these package managers as a way of conveniently storing them somewhere online, not necessarily intended to be used by anyone else. But most search engines don't take that into consideration at all at the moment. Another nice thing, a good way of working out if someone actually cares about the people that may be using or contributing to that open source library is if there's any kind of documentation about how to go about contributing, and if they've thought about the other people that are going to be involved in the conversation. So if you can find any kind of code of conduct or contributing documentation, that's a really good sign that this author or group of authors cares about the people that are using and developing the library that they're working on. Another thing to take into account is the project active? We need to actually look into seeing if this thing is still functional. Again, we don't want to have to literally go through and run this code and download it to work out if it's any good. Can we use some signals to see if this project is active to kind of give us an indication that it's likely to be useful? Has there been a regular release? If you're looking at a project that's not had any releases for the last 5 years, it might raise some eyebrows as why is this project, is it dead? Is the language completely stopped development? In some cases, that's not such a bad thing. In the world of Perl, for example, things don't move very quickly. Perl 6 supposedly coming out very shortly, but there's not been a Perl release for a long time, so the ecosystem doesn't move along very quickly. Whereas something like JavaScript, where there's constantly new versions of Node coming out, if something is, say, 6 months old, not being released, it may not even work on the latest version of the runtime. So it's kind of dependent on the language that it's going to be running in, but the ecosystems that these libraries exist in are constantly moving and constantly changing. So if it's not being kept up to date and not being, not necessarily having new features added, but even just having some kind of functionality tested on a regular basis against other things in its ecosystem, then it may not be any use. Are the authors responsive to bugs? So this is another easy way of seeing if it's going to be something that you'll be able to rely on long term. If you take a look at the issue tracker, if it looks like there's lots of people reporting bugs, but there's no response, completely quiet from the maintainers, that's a big warning flag that something is perhaps not working out, or that the maintainer has completely given up looking after this project. And another good sign that a project is actually still active is if it has any dependencies. Have these dependencies been kept on a regular kind of up-to-date, so that you can see that it's moving along with the ecosystem that it exists in. If all of its dependencies and the things it uses are all old versions. There's been new releases of those. It may not work with other things that you're using if they also rely on those dependencies. On the flip side, has this project existed for any kind of period of time, and is it an established project? You don't necessarily want to jump on something which has only been introduced in the last week and has essentially no momentum behind it or no real kind of base of users that are trying it out. How old is it? So has it been around for a while? Has it become established as and used in the community? Has there been more than one release? It's not just kind of fire and forget. Have the maintainer and the authors been updating it on a regular basis? And how many people have been contributing to it? If there's only one person contributing to it, they may kill the project just by stopping working on it. Having multiple people be able to contribute to it, or even merge other people's contributions means that the project is more likely to stay around for longer. And you would think that we can actually work out some of this by looking at how popular it is in terms of numbers. Can we skip all of these previous requirements and try and get users of sites like GitHub to vet this kind of thing for us? So things like download counts. Can we use download counts of modules to give us an estimation of if something is being used? But there's a problem with download counts, and that is CI systems, which on cross-package managers will repeatedly download libraries. And at the moment, as far as I'm aware, on NPM and RubyGems, the download counts don't filter out downloads from CI systems, which will repeatedly download things many more times than necessarily bumping up the numbers. So you have to take download counts with a grain of salt. Maybe only consider them on a logarithmic scale, as in, has this thing had 1,000 downloads, 10,000 downloads, 100,000 downloads, rather than looking at it kind of up close. Another way which most people, I think, would initially consider how they review their projects, and if they're going to use a library, is to look at how many stars it has on GitHub. But there's a problem with that as well. This is a project that I noticed the other day. It's called Volkswagen. It detects that it's being run your tests are being run in a CI environment, and it adds a defeat device to ensure that your test will always pass. It's written in JavaScript. There's a PHP version as well. And this is really popular. It's got 4,000 stars. But it's only existed for a week, and it's only been downloaded 300 times. So that's not even 1/10 of the number of the people have starred the project, which kind of defeats the point of looking at how popular something is and then actually considering that as usage figures. GitHub stars have become a popularity contest rather than an actual useful number to consider. People use it as a bookmark, but that doesn't necessarily mean that they're actually using the thing. And has anyone here ever unstarred a project on GitHub? No. Well, one guy. Basically, once you've starred something, you're never going to come back and manage those things again, because why would you? There's no benefit to doing those things. You don't use it in the same kind of way as actual bookmarks or managing these things as going, oh, yes, I like this. I'm not using this anymore, so I'll unstar it, because people don't really search through their GitHub project using stars, and there's no real benefit to it. Another project that's very popular on GitHub is called Dancer.js. I used this myself a couple years ago. Good 2,000 stars. You think, oh, this looks like quite a good project. And it works with the HTML5 audio APIs. The problem is that those have changed considerably over the last year, and evergreen browsers update themselves automatically, rendering their demos completely broken. But from a GitHub star perspective, you wouldn't be able to know if that project looks quite good, right? No one's gone through and unstarred all of their projects because they don't work anymore. This project is essentially dead and hasn't been updated at all. So you can't really use GitHub stars in a way to filter out if a library is good or not, because there are so many false positives in there. Another interesting idea I saw someone suggest a couple of weeks ago is to look at how popular something is on Stack Overflow. Lots of people asking questions about it or answering as a means to see if that thing is actually active or not. And it's interesting, but that doesn't necessarily mean that it's actually any good. So Angular has an order of magnitude more questions asked about it than other popular JavaScript frameworks. But does that mean that it's used more widely, or that people have more problems with it? Is it easier to use because it has less questions, because people just understand it and know how to use it? It's not clear, but as far as I can see, really the only indication is of a certain level of activity around those things, and it really only works for really big popular frameworks. Small libraries won't even appear on Stack Overflow as a tag, so you have to search for the particular name, and if that name is a generic name or just a regular word, you're never going to find it. Ultimately, what we want to work out is that library a dependable thing? Can we actually depend on that to provide us some functionality? And really, what I found to be the best metric to do this with is to see how many people depend on it. So looking at the amount of other libraries and applications that rely on that particular library turns out to be quite a good metric for finding out if something is useful. So let's have a look at how dependency trees work and how we can actually step on to find out the amount of people that depend on something, and how we can generate a metric to use for a given library to work out if it's actually good or not. So we'll take Ruby on Rails, which in itself is a very popular gem, and it depends on a number of other projects. So each of these projects, a lot of them are actually built into the Ruby on Rails ecosystem, but they're deployed as separate libraries that can be used externally. As we can see, Rails depends on a number of gems, and then those gems in turn depend on things, some of them depending on the same. Have I got a laser on this? I have, but you can't really see it. Say Nokigiri down the bottom there, which is pretty tiny, hard to read, but for most high-level libraries, they're going to have extra dependencies that they bring along with them. This is a rather crazy node module, which is called download. It's literally, its only function is to download a file to your file system, and this is its dependency tree, which is absolutely crazy. But as you can see, we've got libraries down the bottom here which are used multiple times, or you can't see because it's so small just to fit it on the slides. But there are similar libraries showing up here multiple times, which are used across a broad range of different dependencies. It just happens that this particular library uses a huge amount of first-level dependencies, which then pass on to being a massive dependency tree. But if we map this out for a whole ecosystem, say the Go dependency tree across all libraries that are available for Go, we can see the connections here. This is a visualization from an open source project which pulls in package managers and visualizes them as a 3D graph. And it looks kind of similar to the internet. This is a project that has tried to map. Can you even see that in this terrible light? Probably not. But it tries to map the internet into a similar kind of way of connecting all of the nodes together and then visualizing it as a map. And famously, Google built an algorithm, PageRank, to be able to map the connections and find the most valuable, most interesting or important websites by looking at the different connections between them. So this is a basic description of PageRank. And we can actually apply that same description to our package manager world. So replacing web pages with libraries and replacing links with dependencies, we end up with a very similar graph. And we can actually apply the same algorithm to our dependency graph as to web pages. So just to visualize that, this would be a kind of a simplified visualization of PageRank, where pages that just link out have a PageRank of 1, and they then pass on a certain amount of PageRank onto, say, meetup.com, which, because it's receiving a bit of rank from each page that links to it, that then passes on more PageRank onto pages that it links to. I'm describing this terribly. If we swap this out for dependencies, it works in exactly the same way. So we've got a load of little libraries that depend on Express. That boosts up Express's rank. And then when Express depends on Mocha, which almost everything else does, Mocha being a testing framework, that really boosts up its rank. If then Mocha depends on another library, it passes on a percentage of its rank. One thing that you won't usually have in a package manager situation is then that thing depending back on Mocha, because circular dependencies tend to make a bit of a mess of things when you're installing them. So we'll imagine there isn't a little red arm there. And what we're really doing here is we're looking at what people do rather than what they say. So with GitHub stars, people are going like, I like this thing, but they're not necessarily using it. There's no indication of what they're doing. They're looking at the dependency graphs of a number of package managers actually gives you the indication of what people do, what they're using, what they're relying on. And those numbers work out to be much more effective. But there is a problem. And what we've done so far to map out a particular package manager really only works for libraries that are depended on by other libraries, very utilitarian, very low-level libraries that other libraries would use, but you may not use those in your application development. So if we imagine this is the Ruby gems world, if you can see that, that's kind of hard to see. But what we've got mapped out so far is the dependencies of libraries against other libraries, not building out a useful picture for application dependencies. So what we need to do is we need to look at all the applications that depend on libraries as well, which is a little bit more tricky. We need application level dependencies. And by this I mean we need to look in every application, open source application, and look at what it depends on, as well as what each library depends on. And to do this, we need to look at manifest files. So this is things like your gem file, your package.json. In Java, I think it's pom.xml, or I think. And there are files for almost every different package manager that will allow you to specify the dependencies of your application. And there are different ways and different formats. Some are really easy to read. Others are, say, Clojure written in Clojure, which means you need to pass them by executing files. But I've been working to essentially index and pass all of these different things. The resulting outcome is libraries.io. So what this does is it indexes all of the packages from all 29, I say 29, there are more, but so far I've indexed 29 different package managers. And that comes to over 1 million libraries. written in over 160 different languages. I didn't know there was 160 different programming languages. Turns out there are some really obscure, random ones. And then I've gone through and trawled GitHub for about, so far I've got 2.5 million GitHub repositories. There are a lot more GitHub repositories than that, but I've run out of disk space on my database machine right now, so I've kind of frozen it at that point until I can afford a bigger database machine. But the idea being then, for each of those GitHub repositories, I've pulled out the dependencies from the application and linked them to the libraries that they depend on, so that you can actually see a holistic view of the dependency graph of all open source. But rather than actually trying to visualize that, I fed that back into a search engine using that rank, very similar to PageRank, to help boost search results rather than so that you can effectively have Google search for searching across different libraries. So let's look at an example. Here we have a search across Bower, which is a front-end package manager. Search for something to convert XML to JSON. And as you can see, their search is pretty appalling. The first result has nothing to do with the converting between those things, and neither does the second one. Libraries search actually comes up with a number of relevant results ordered by their kind of popularity and the amount of times that they're depended on. So it's looking at how many dependent applications and libraries each of these search results has and then ranking them accordingly. And then allowing you to filter down by different things as well. Similar for NPM. We've got two libraries here, but this top one hasn't been updated in a long time. Oh, I didn't know I could control the volume from here. And the resulting search here is just much better. So we have the exact, or the closest you can get exact match on the top. And then the second result is the most popular in terms of GitHub stars, but the top one is actually the most depended on across all the applications that it's indexed so far. Again, we're looking at what people do rather than what they say. So GitHub stars don't necessarily mean it's the most popular thing. Actually, the amount of people that depend on a library gives you a better indication of if that library is still dependable, because if it stops working for any reason, they're going to stop depending on it, and its natural ranking will go down. So as long as we keep working over the graph in the same way that Google keeps indexing the web, we can keep seeing an updated version of what kind of the snapshot of the open source world looks like. If we look at GitHub stars, we'll continue to peak upwards unless we have some kind of way of decaying the value of a star over time. And we find the most dependable libraries across each ecosystem as well, which end up being the most important libraries. If thousands of people are depending on a particular library, then that's actually, we should be considering those things as key pieces of infrastructure for the world, right? There's potentially tens of thousands of applications which millions of people are depending on to continue to keep working. And so what I'd like to start doing is to use this data to encourage and help the open source world so that we can enable people to give back to open source in better ways. One of these experiments I've started to do is to help out the bus factor. Has anyone here heard of the bus factor? So the idea of the bus factor is how many people need to get hit by a bus that are working on your project to make the project kind of stop completely. So if you have one person working on the project, literally if that person gets hit by a bus, then it completely dies at that point. Hopefully they don't die, and once they've recovered, they can come back to it. But you can replace the word bus with truck or plane or train. The result is the same thing. And to simplify that, we can actually look at the data that libraries is indexed in a really fairly easy way. If we look at the number of contributors and the rank that it has, ordered by the projects with the least contributors that have the highest rank, so the most people depend on this project, the most important projects, then we end up with the projects that have a really high bust factor that we should actually be worried about. We're essentially saying this project here has got, I don't know if you can read that, 352 dependent libraries. So there are 352 other libraries that depend on that library, and there's only one contributor. That means that if that guy stops working on it, or dies, or just burns out and is not interested in doing any further software development, that not only is that project frozen, but the 352 other projects that depend on it, and any projects that depend on that, all need to be either updated to switch to another version, or have to essentially fork this project. But most likely, those projects will kind of freeze in time, potentially won't get the correct software updates or security fixes if they need to. And this is a really good way of essentially taking whatever effort and energy that you put into open source contributions and multiplying it so you can put your work into the most valuable place. If you've only got, say, an hour a week to do open source contributions, you can make that hour count a lot more by contributing and helping out with a project that maybe there's a guy who's a little bit overwhelmed or doesn't have enough time to be able to help out with these things anymore. But these pieces of essentially infrastructure that is relied upon by so many other people are valuable places to make a contribution. Similarly, we've got, as I said before, over 30% of all the libraries that I've indexed have no license or a strange kind of non-standard license, which if you're working on top of open source and you go to, say you sell your company that you're working on, you may find that you've been relying on a piece of software which in its license somewhere along the line says that any code that you build on top of it must be open source. If you've not, or if it has no license whatsoever, you were never allowed to really use that in the first place, that could put you in all kinds of sticky situations. And a lot of these libraries are being depended on without any real license. So we've got another fairly easy SQL query we can do there across the data set to find the libraries that are most depended on and have the highest rank, which have no license. So there are some of these will have a license somewhere in another project, but there are a good number of libraries here that have no license but are depended on by hundreds, maybe even thousands of people. So this is another good place to put some energy in to effectively ask these maintainers to add a license and improve the situation considerably by focusing on the most important libraries that need the help. Rather than kind of having a broad shotgun approach, we can have a laser focus to just put in a small amount of effort in that has a big impact. And this strengthens the foundations of the programmer community of the open source world. We're essentially making sure that all of the things that are most relied upon have the support that they need, are set up correctly so that they're legally allowed to be used, and ensure that we don't end up with things like the Heartbleed exception, which happened in OpenSSL. There was very few people actually looking at a thing which most people depending on in one way or another. And no one was really aware that that thing wasn't getting enough interest. Maybe the NSA were aware and kind of intentionally using that, but we're able to then look at, okay, well, what are the most important libraries that haven't had a security review recently? Probably a lot on GitHub have not had a security review recently, and then we can actually potentially even fund security researchers to look at the libraries that we consider to be the most popular because they are depended on by the most people.
And this helps people make more of an impact with any open source contributions that they make. So if they only have a short amount of time, or they want to get involved in open source some way, they can actually have more of an impact just by looking at the dependency graphs of a particular package manager in a community that they are interested in or they're experienced in, and find the areas which they can make the best contributions for. So, thank you very much for listening. Are there